Now, when you have a tree diagram with dependent events, that is, the second event actually depends on the outcome of the first, you can use the exact same type of tree diagram. You've just got to be really careful when you go to write your probabilities on the branches. So this example should explain it. I've got 3 red and 2 green lollies in a bag. I take a lolly without looking and I eat it, and then I take another and I eat that too. What is the probability that I have 2 red lollies, 2 green lollies, or 1 of each colour? Well, if there's 3 red lollies in the bag out of 5 lollies altogether, the chances of taking red in the beginning is 3 out of 5 and green 2 out of 5. But once I've eaten that first red lolly, you have to reconsider and sort of think through, imagine acting this out. There's only actually 2 red lollies left out of 4. So the chances of getting red this time are 2 out of 4, and obviously we've still got our 2 green lollies. Now you might look at that and go, hey, that's exactly half. Why are you writing 2 out of 4? But I found that if I keep the denominators the same all the way down, it makes it easier for me at the end to check that everything adds up to 1, because everything's going to have the same denominator. Now, if I've already eaten a green lolly, there's only 1 left, so the chance of getting the next one green, 1 out of 4, and I can easily see that we've got all 3 red lollies left, 3 out of 4. Now I can multiply, and I can see that all of these probabilities are going to be out of 20 because the denominators are 5 and 4. Now I can quickly multiply the numerators and get 6, 6, 6, and 2. And 3 6s are 18, plus 2 is 20, so I can quickly and easily see that my probabilities look right. Okay, the probability of 2 reds, well, that would be this one, 6/20ths, which I can now simplify to 3/10ths. The probability of getting 2 greens, that would be this one, 2/20ths, which I can easily simplify to 1/10. And the probability of getting 1 of each colour, well, if you don't mind what order you had, then you'll need to add up the 2 ways that that could have happened. You could have had red-green, or you could have had green-red. Both of those are 1 each, so we need to add them. And we get 6 plus 6, 12/20ths, which is 6/10ths or 3/5. And we simplify our fraction down as a last step. So it's quite straightforward. You've just got to take care and think through what happens when I eat that red lolly. There'll be less of them. And I think once you sort of tell the story there, these probabilities are quite simple. If you figured one of them out, you'll notice that each set of probabilities adds to 1. So if you figured one of them out, the other one will be the complement of that.